I made the exam. It is made. It is as promised. There's one problem in Excel with 3 parts, A, B, and C. You guys do 2. So one is a bar chart, one is descriptive statistics, and the third one is a pivot table. So would you like, we can do whatever you guys like today. Use our time as you like. Would you like to do one of those? One like that? Would that be something? Okay. So I guess I will go out and let's just grab a file and we'll do that with that file. So let's see, sample exams. How's final week's going, all right? Dreary weather, huh? So let's go to, how about we'll use this? Go to first, this is under sample quizzes. It says first Excel quiz sample. We've used this file before, but sample sales data, 500 transactions, might as well use the same one. And it looks like this, a whole bunch of data. If you go under, it looks like it's sample exams. And then there's a folder that says first Excel quiz sample. You guys can see that, yes? It's not at the bottom, maybe? Yeah. And then it says sample sales data, 500 transactions. All right, so first things first, if I were to tell you to make a bar chart of region, okay? A bar chart of region, that's nominal data. A couple of ways you could do that. Give me one way you could do that. Go ahead. Yeah, so one thing I could do is I could do a count if. So looks like I have east, west, central, blah, blah, blah. Okay, so one way I could do that, I could come over here and say, what row is that in? What column, I'm sorry? M. Okay. So I could say region and east, central, west, and one else. What was the other one there? East, central, west, south. Did I see the south there? South. Yeah, east, west, central, south. Okay. So I could do frequency. And you're right, I could do a count if. And I would do M2 to M501. And I would count whatever's in AB3 or 2. So remember the count if will spin through M2 to M501 and count the number of east it finds. So I'm going to use an end parenthesis here. And it says 126. Now, I'm going to copy that down, but before I copy it down, what part should I make absolute? And what key do I do absolute with? F4. So I'm going to highlight the M2 to M501, do the F4, and I'll drag that down. And I might as well sum it. I think it says 500 transactions, but there's only 499 actually. So we have to do that before we do a bar chart. If we're doing the count if method, what's wrong there? You didn't get that, Eric?
I have every number except central is 0.
Did you spell central right?
Probably spelled it wrong.
Did you put a space after central?
Yeah.
You put a space after central? Yeah, that's why. Okay, so it has to be exact or it won't find it. So all I have to do now is highlight the region and the frequency, do insert, I'll insert a column chart or bar chart. And we have our chart. Now you guys remember, hopefully you remember, a lot of things we can do here. First thing I would start with a quick layout, and we've been using the 9th one because it gives us an axis title for both the x-axis and the y-axis. It gives us a legend, which we really don't need, so I'm just going to delete that guy. And I'm not going to take off points, but if you want to make it a hot chart, you can do that, certainly. So to change the title, you just click on it and type whatever you want. You guys, so this would not be good because frequency is not a good title, axis title is not a good title, but it's getting better. And then the one thing I would want you to put on here is data labels. You guys remember how to do that? Hit the plus and check data labels. And that's one way to do that. Okay? So that's a bar chart. That would be, you'd shove that into Word, you'd write a couple sentences, looks like most sales are in the West, and least sales are in the South. Boom, that's good. Now, how's the other way I could create that bar chart? Probably an easier way. Any other way I could do that? Come on, what other tool can I use? Yeah, pivot table. So since I'm just creating a pivot table based on one column, all I'm going to do is highlight column M. So I'm going to check the M or select M. Do insert, pivot table, click OK. Drag region to the rows, drag region to the values. And we should have the same numbers there. But you might say, well, that's not a chart, that's a table. You're right. But I can go up here and now click on pivot chart. And I get this pivot chart. Now, we have to do a little bit to make this look nice because it's a pivot chart. So we can still do the quick layout 9. And I really don't like having those buttons on there. So I think we can get rid of those by going under Analyze and click Filled Buttons, and they're gone. We can delete the legend, and we can also sexify it. So, and I'd put on data labels. But, oops. That's two ways. Oh, the other thing I'd get rid of is what? I don't like that blank. So we could just, if we change it over here, these two things are tied together. So if we go over here and just filter out blank, it'll go away from our chart as well. So that would be step A, right? That would be A. If you did A, you've done with A. Like B would be something like, I don't know, let's say analyze the sales field. Okay, so X is the sales field, and I would ask for mean, median, mode, variance, standard deviation, basically everything that what gives you. I would do data analysis, descriptive statistics, click OK. My input range is the whole way down, X1 through X499, X500, I'm sorry. There are labels in the first row because it's a label. And I want summary statistics, and I click OK. And it kind of gives me all those things nicely in this table. And I can say, well, the average sale was $875. The median was 194. The variance, standard deviation are here. The range is pretty wide, but I have all those data points there. And that table is really all you need. You can just describe it a little bit, but it kind of does everything at once. Okay. The part C is kind of another pivot table. So if I would ask you something like this. I would say by region and department, give me the count of sales and the sum of sales. Okay, by region and department, give me the count of sales and the sum of sales. So I'm just going to highlight everything. So I have all these fields available to me, A through Z. I'm going to do insert, pivot table, click OK. And I think I said what, region? So I'll drag that there. Did I say department? Department, I'll drag that below region. And for those I said sum of sales and count of sales. So I'm going to drag sales down here once. That's the count. I'll drag it down again. It gives me count. But what can I do to that count? I can do value filled settings and change it to sum. While I'm in there, I might as well make it look nicer. So I'm going to change the number format to currency with no decimal places. So now I have, hey, we sold in the central division, we sold 18 sales of furniture for $26,743, right? So I don't think I asked you to do a slicer. Maybe I can't remember if I did or not. But if I did, if I said insert a slicer based on, I don't know, customer segment, you just do insert slicer, customer segment, click OK. When I'm on the pivot table, under Analyze, under Pivot Table Tools, there's an Insert Slicer button. And then you check what you want to slice on. So I said customer segment. So you'd have to do, I should have made you do all three, but you have to do two of those three, right? A and B, or that was C. So A and C, B and C, C and A, any of those combinations. That'll be worth 20 points, right? So what you're going to do is, whatever you choose to do, you'll copy it into one Word document and upload that Word document to Blackboard. And I'll grade it online. Okay? So questions on that? So it's nothing more than that. So if you could do, I recorded this by the way, but if you follow along with that, you should be able to do 20 points to this exam. Yes?
We're supposed to do those sentences too, like we did with the
Yeah, I want you to, like when basically a sentence or two says like, looks like the South is leading in sales or the West is trailing, whatever it might be.
Okay.
You know. Okay. So so after you'll do that first, and then you will do this written exam. And once again, it's open book, open notes. And I'm looking. I think I told you 35 multiple choice, right? 35 multiple choice. That's what we have. 35 multiple choice. 30 you've seen before. 5 basically on the normal curve. Okay. So I'll tell you this. The first 3, oh, I have a typo on the first 3 already, is basically one where it's a little word problem and asks you to pick out the parameter, the statistic, the population, the sample, right? You remember that? So those were easy. So that's 6 points. You can do that. That's 3 multiple choice. You get out of the park at the beginning. And you remember the parameter went with the population, statistic goes with the sample. You remember that? You guys remember those things? Yes? Okay. So then that was like the first 3, then 4. Looks like 4 through 10. Are all related to chapter 2, which is charting, right? So know what type of chart is for what purpose. So if I were to ask you, well, first, let's put a stop there for a second. Know the three types of data, right? There is interval, which is numeric data. So anytime you see money, height, weight, temperature, that is interval, any real numbers interval data. There's two types of categorical data, nominal and ordinal. And the difference between is ordinal means it can be ranked. And not just by you, but it's implicit ranking. So, all of us know that excellent is better than very good, and good is better than fair, and fair is better than poor. All of us know that extra large is bigger than large, and so that's ordinal data. If I say what major you are, that's nominal data, right? Accounting is not better than finance. We can't say that, right? We can't say marketing is better than accounting. Okay? So know that. Now, when comparing two sets of, first, if we just have nominal ordinal data, one piece, sorry, I got like a tickle in my throat. It's just like right there. Those are nice socks, Brandon. I do. For St. Nick Day, my twin, who's 8, he's a character. He's a real character. We got bacon socks, Star Wars socks, and we got 3 pairs of like crazy socks. What? It seems like those are coming back, like personality socks. Why?
Yeah, I think all my other socks are dirty.
Well.
It's the end of the semester,
Yeah, I understand. All right, so if I have nominal data, just one set of nominal data, there's 2 methods I can use to chart it. What are the 2 methods? We just did one of them. Bar chart or pie chart. If I have one set of interval data, what can I use to chart it? Not line. The histogram. You remember the histogram? If I have interval data over time, what do I use? Scatter plot, right? Scatter diagram. No, line chart. What are you killing me, Eric?
Oh, yeah.
Yeah, if I have data over time, it's a line chart. Histogram is when I have one piece of interval data. Yeah, data over time is a line chart. And now if I'm comparing, this is what Eric was getting at, when I'm comparing 2 sets of interval data, I use what? Scatter. What is on the X, what is on the Y? X is the independent variable, Y is the dependent variable, right? We think X determines Y. You guys remember that? Like we think temperature determines ice cream sales. The number of hours you spend studying determines your grade. Remember those things? The X independent variable determines the dependent variable. There's one like that on there, I can guarantee you. Actually may have said it. So, okay, then there are, let's see, a few questions about numerical descriptive statistics. So when we talked about numerical descriptive statistics, we talked about measures of central location, measures of variability, measures of relative standing, and measures of linear relationships. So know what those are. Like measures of central location are things like mean, median, mode, right? Geometric mean. We use geometric mean when we have rates of change. Measures of variability are range, variance, standard deviation. Higher numbers of those things indicate what? Any higher range, higher variance, higher standard deviation means the data is more spread out, right? So you guys remember that example, I think it was in the sample test, like me and Brandon are both 3.0 students, but he has a higher higher standard deviation than me, so that means who's more consistent? Me, right? The person with the lower standard deviation is more consistent. If me and Kira both invest in 2 investments that have an average return of 10%, but mine has a standard deviation of 5% and Kira's is 1%, who has a more risky investment? me because my standard deviation is higher, meaning, could go up or down more, right? More inconsistency, if you will. There are some Z lookups. Maybe one, maybe two only. Can you guys do Z lookups? But you have to do it for the problem as well. You guys feel comfortable with Z lookups? Okay. Huh? You say something, Lee? Okay. Ooh, probably an accident, you think? I might just sleep at Schwab tonight, I don't know. Anamushi's probably open, isn't it? Brandon, where do you live? I'm crashing.
Where do I live?
Yeah.
Lewis, man.
Lewis?
Lewis,
Oh, man. That would be like
Lewis,
fantasy
that's
camp for me, to tell you the truth.
Well, Lewis, man,
I lived in Lewis 107 for 2 years.
I'm getting there, man. I'm getting there.
I was in first wing for 2 years, first main for 2 years.
You should get one.
133, I think, was my room my freshman. Then I was the RA in first main.
Not my second year.
First main. You were an RA?
No.
Oh.
He just got stuck in.
Yeah.
Oh.
Bad job.
Huh?
Do you guys bring a horse or a cow?
It was a cow, yeah. I didn't do it. I wasn't an RA then, thankfully.
They all work hard.
All right, okay, so this one's probably a little bit tricky. So if I told you, on average, one student visits my office every 5 days, every week, every day, let's say. And I'm trying to figure out the probability that in 3 days, 5 students visit me, okay? So on average, a student visits me, I average 1 student per day in my office. If I'm trying to figure out the probability that 3 students visit me in 5 days, what's the mu and what's the x value? Probability that 3 students visit me in 5 days. So the x value will be what, Ram? X is 3. I'm trying to figure out the probability that x is 3, but the mean would have to be adjusted. So if it's 1 student per day, what's the average for 5 days? 5. So there's one that asks you to adjust the mean, basically. For a home. What is the most important continuous probability distribution? The normal curve. Very good. What is the mean and standard deviation of the standard normal curve? What is the mean and standard deviation of the standard normal curve? The mean is 0 and the standard deviation is 1. Very good. So time, if time is a random variable, is it discrete or continuous? Continuous, right? We can always slice time thinner and thinner. Assigning probability. Remember the 3 methods we use to assign probability? Classical, relative, there's 2 of those on there. Classical, relative, and subjective. So if I say I'm going to pick a person to exempt from the final randomly by picking 1 person out of that group, so the odds that you're exempt is 1 out of 30 are in here. What method did I use to assign that probability? Classical or mathematical, right? If I say, historically speaking, anytime I say historically speaking, relative frequency, if I look back, if it's based on my expertise, subjective. I'd say Brandon looks like he's having a tough week, I'm going to exempt him. That's not really, that was a bad example. Never mind. And it was out of context. If the probability of A is 30%, what's the probability of the complement of A? That's a no-brainer, right? That's a softball down the middle. If I increase the mean of the normal curve, what happens to the curve? If I increase the mean, the shape doesn't change, what happens? It shifts to the right. If I decrease the mean, it shifts to the left. If I increase the standard deviation, what happens to the curve? flatter and wider, right? If I decrease the standard deviation, narrower and more peaked. So the multiple choice, like I said, shapes of histograms. So if I drew this histogram, hey, who's that bell shape? That's pretty good. What'd you say about that? That would be a bimodal, very good. If I drew this, what is that? Skewness, what's the skewness? It's either positively skewed or negatively skewed. Positive, because most are front. Going down steps is positive, going up steps is negative. And obviously, if it looks like a bell, it's bell-shaped, right? Symmetrical. You get it. Somehow I didn't put any multiple choice about percentiles on here, I don't think. Oh, I must have missed that. Yeah, I did. All right, so any questions on the multiple choice or anything you can remember from the multiple choice that was tricky or that you didn't understand the first time through? Okay, so the problems, you have to do the normal curve one because we've never been assessed on that, right? So you have to do that one. And then you have to either do one of, there's a probability tree and a conditional probability, joint probability table. So let's do, let me make up, I'll make up one real quick on, let's say, the average time it takes a student to complete my exam is 90 minutes with a standard deviation of 10 minutes. Okay? So it's normally distributed. So if I asked you this, what's the probability it takes a student longer than 90 minutes? This could be in the multiple choice of set semis. Marcus, you said it. Not 10. Half, so 50%. All right? What if I asked you, what's the probability it takes a student less than, I don't know, 75 minutes? Less than 75 minutes, okay? What would I have to do? I'll give you this formula. What would I have to do? Convert it to a z value. Should have done on there so it captures. The probability that z is less than 75 minus 90 divided by 10. That gives me the probability z is less than negative 1.5. Now, since this is, and I give you the z table.
But you said you're going to give us that formula, right?
Yeah, you'll give it. But you also have your book.
Yeah.
But yeah, I'll give it.
I wouldn't find it.
But this is less than, so what do I need to do? I just need to do a lookup, right? So I go, I don't have my table with me. I go to my office.
Yeah, it's all here. It's fine.
So, this is negative 1.5. So it's less than, so I don't have to do anything to it. I just look up the value. It gives me 6.68%. You guys see that? Yeah? And I give you, so that's a less than. All you have to do is look it up, right? No big deal. If I say, what's the probability that x is, I don't know, greater than 94? Okay, well, I have to convert 94 to a z value. 94 minus 90 divided by 10 gives me the probability z is greater than 0.4. Well, this is a little different. I'm going to look up 0.4, and I get 0.6554. But remember, that's this way, 0.6554. That's area to the left. So how would I get area to the right? Always on greater than, I'm going to end up doing what? 1 minus. So 34.46. And then I'll give you a between one, right? Like, so what's the probability that someone takes between, let's say, 80 and 110 minutes? I need to convert both to a z-value. So the probability that z is between 80 minus 90 divided by 10, 110 minus 90 divided by 10, gives me the probability z is between negative 1.0 and positive 2.0. So when it's a between deal, I look up the big one first. So 2.0 gives me 0.9772. And then I look up negative 1.0, and it gives me 0.1587, and I subtract. I don't know if that's right. We'll go with it. Okay. And what if I asked you this one? What's the probability that it takes someone, I don't know, under 3 hours, which is what, 300 minutes? Well, probability z is less than, let's see, 300 minus 90 divided by 10. That gives me probability z is less than 27. That's 207. Probability z is less than 27. You're gonna get a number like that and be like, oh, what, Dr. Miko, it only goes to 3.89. You're gonna come up to me. You're gonna panic. Your neck's gonna be red. You're gonna be shaking because it's not on the table. And all you have to do is what? Right, because you think about it, it goes 3.89, negative 3.89. What part of the curve is less than 27? Everything, right? Virtually 100%. Okay. So that is, actually I have, so there's like 5 parts to it, but that should be easy. Okay, and then there's a probability tree one. I'll do it on here so we can see it. So let's say, we'll use that example I used before. Let's say I say that 50, about half, I'd say 60% of people attend this study session. Of those that attend this study session, what's that? What? Gets points? No. 70% get an A. Of those that don't, only 30% get an A. So define the events. So attend, don't attend. Oh, I shouldn't have used. Oh, man. Because I want to use A for, yeah, I see what I did. What's another synonym for attend? Come. All right, P or F, we'll say P or F for the other two, okay? So P means pass, F means fail, even though my example was A. So I said that about 60% attend. Oops. That means that 40% don't attend. I said, given that you attend, 70% of them pass. And if you don't attend, still 30% pass. So I only gave you 3 probabilities, but you can still fill in the rest of this tree. Why? Because remember, this has to add the 1. 60%, 40%, every place it splits has to add the 1. So if you attended, 70% pass. If you attended, what percent fail then? 30. If you didn't attend, what percent fail then? 70. How many outcomes do I have here? 4, because there's 4 ends to the tree. If I asked you what percentage pass, let's see, these guys pass and these guys pass. So 60% times 70% is 42%. 40% times 30% is 12%. 54% of Dr. Miko's students, well, it's going to get an A really, but we said pass. If I asked you specifically what's the probability that someone doesn't attend and fails? If I asked you for the join, how would I find the join? Doesn't attend and fails. Max?
You just like follow it down the tree.
40% times 70% or 28%. So that one should be easy as well. Let's say so let's say Dr. Miko all right, so this is pass, this is fail. That's not very good, but anyways, I don't like when it comes out to be non-realistic. But anyways, if I give you this joint probability table of male and female and pass fail for this, let's say it's Science 101. Shouldn't have recorded that either, huh? So first thing we do when we get a joint probability table is we add down the columns and across the rows. So this is 40%, this is 60%, this is 50%, this is 50%, and we get 1 point out. Okay? So if I asked you, I said, what percentage of people pass Science 101, what would you tell me? Where do you look for that? Into the margin, and you say 40%. What percentage of students are male that take Science 101? Where do you look for that? Into the margin, 50%. Good? If I asked you what percentage of students are female and pass Science 101. So you heard that word and, that's the key. You heard that word and. They're female and they pass. What would you tell me?
20%.
Where it intersects, because this is a joint probability table, so where they join is that probability. Now the thing you guys missed the last test at an alarming rate was the conditional stuff. So if I said this, if I said, if the student is male, what is the probability he passes? If the student is male, what is the probability he passes? If the student is male, what is the probability he passes? So what is the given part that I want to put second? What is the known part? If the student is male, so given he's male, what's the probability he passes? So I'm going to join the two, probability of pass and male, divided by the probability of the second thing, which is male. Let's see, pass and male joins at 20%. Male is 50%. So 20% divided by 50% is 40%. So the probability that someone passes, given that we know they're a male, is 40%. Now here's the big question. Are these independent or dependent? What do we need to compare this to say if it is independent or dependent? What's the probability someone passes if we don't know anything about them? What's the probability someone passes if we don't know anything about them? 40%. Overall, 40% pass rate. Given that they're a male, the pass rate goes to, it stays the same. Because they're equal, we say these events are independent. If they changed, if this went up or down, it would be dependent. Remember that? Because it means it matters. If it mattered, we'd either say, well, maybe this teacher is biased against males or females, or maybe make some kind of other non-politically correct hypothesis. I don't know. There's also 2 bonus point opportunities, which are gettable, meaning you should all get them. I mean, they should be 100% of a get. All you have to do is like sign a contract for one and take something for one. You can all do it. So 3:30, Schwab 106, which is the big room downstairs, the big wide room that Dr. Fry teaches in, and Dr. Eklund, the big wide one, which is a nice room, but it's too wide for me to teach in. I don't like to be that wide. But for test examination, it'd be good. Sean?
Are you putting this on the lecture tab?
Yeah, I recorded. I'm going to try to upload it right after you guys leave. I'm going to try to make it home safely. If not, I'm staying in Lewis.
What else would you do?
107. Probably hasn't changed, has it? 25 years?
No, they updated in the summer.
They updated in summer, really?
In the summer. Yeah, we're living good.
Check it out.
I'm living good.
Yeah?
It looks a lot nicer in there though.
Really good too.